Section 4.6 is about arithmetic sequences. Yes, that is supposed to be pronounced arithmetic, not arithmetic in this case. Arithmetic is what you do in like first grade. These are arithmetic sequences. So we are going to write them as functions. All right, our first example before we even get into any notes is to describe the patterns that we see here. So on the first one, what do we notice about these stars every time we go to a new instance of this problem? It does what?
Adds up about ones.
Okay, we add 1 star every time. So add 1 star each time. That's a good description. What about the pattern on the second one? Annabelle, what do you think?
Add 2 dots each time.
Good, we add 2 dots each time. And 2 dots. So our patterns that we're going to talk about today are going to involve something similar to this, where we're adding something every time. Now, you might notice these ends up here on the first one, they correspond to how many stars we have. That's kind of a coincidence. It does not always happen that way. For example, on the second one, when we have n equals 3, we actually have 6 dots. So these n's we consider to be like a position or an instance for these problems. All right, let's get into the actual notes for this. If we are writing the terms of arithmetic sequences, we need to know that a sequence is an ordered list of numbers. It has to go in a specific order. Each number in a sequence is called a term. Arithmetic sequence is an ordered list of numbers in which the difference between each pair of consecutive terms is the same. The difference is called the common difference. Now, something I will add, and this might come up again later, is that if you see something like a sub 1 or a sub 2 or a sub 3, these little 1, 2s, and 3s down here, you'll see other numbers sometimes too. That's just listing off which term it is. So this refers to the first term. A with a little 2, what do you think that refers to? The second term. And of course, a sub 3 is the third term. So there's some new notation that we have to get used to. Why they use the letter A to refer to terms, I don't know. Somebody chose it long ago. But we can have a sub whatever number we want for the terms. Okay, also down here, the difference is called the common difference. Now that letter makes a little more sense. We use a D to represent the common difference. We'll see that again here soon. Questions about anything on this slide? Number 2, write the next 3 terms of the arithmetic sequence. So in order to do that, we need to be able to find the common difference so that we know what's happening each time. So if we look at the numbers from -2 to 6, what happened?
It added by 8.
They added 8. What about from 6 to 14? They added 8 again. 14 to 22. Same thing. That's our common difference. So in this case, our common difference D is a positive 8. So what would be the next term of this sequence? 30. What would come after that? 38. And the one after that? 46. Okay, we listed out 3 because they said the next 3 terms. Okay, go ahead and try B and C. See if you can figure out what the common difference is and what the next 3 terms should be. Wonderful. All right, what's the common difference on letter B? -7, good. So what are my next 3 terms? -35, -42, and -49. Questions about how we got those? All right, what about the common difference on letter C? 12. So my next term after that, and then 60. Good.
Is this all going to be on the test?
Yes. All of chapter 4 is fair game for the test. Okay, questions about finding terms in a sequence? Okay. All right, on letter A, they are asking us to graph the arithmetic sequence. Oh, let me get out of that. Back, there we go. Graph the sequence. What do you notice? So, we will do that together. If you want to make yourself a little graph, you can. I think I'm out of graph paper right now. So one thing that's important to realize is that we do have to graph these as ordered pairs. So our ordered pairs, one way of writing it, I don't want to make it too confusing, but the first number in the sequence is going to have a 1 for x. The second term has a 2 for x. So we kind of just number out our x's for however many terms we have, and then we fill in the y coordinate based on the number that's actually in the sequence. So what was the first number in our sequence? 24. The second number, 18. The third number, and the sixth number. The fourth number, 6. All right. I will pull up a grid so that we can do this together. I am not going to count by ones on my y-axis because that's going to make my graph really big. What do you think I should count by on my y-axis? We could go by 2s. I like 6s best because each of these is divisible by 6. We could count by 3s, 4s, something else. My my x-axis, I'll still count by 1s. 3, 4. But here I am going to go by 6s just to make it a little bit easier on myself. It will not always work out this nicely. Okay. But if we graph these points, so 1, 24, 2, 18, 3, 12, and 4, 6. The question on your paper was, what do you notice when we graph these?
It's negative.
More generic than that. What do you think?
The y adds up by 6 as the x's go by 1s.
That's pretty specific. In general, what happens with these points?
Either like based on the numbers behind it or in front of it.
You're still getting awfully specific.
Decrease,
Liam?
decrease.
They're in a straight line. We should be able to notice that these fall in a straight line. So yes, we can talk more specifically about things going up or down by certain numbers. We were close when people were saying it was negative. I'm assuming you meant a negative slope, and that's true. But what we should notice, just on a most basic level, is that these points form a straight line. Do we see that before it disappears? Okay. So these points form a straight line. So under what we notice, points form a straight line. Okay, so let's move on to the next one. In our next sequence, before we graph it, we should identify our points again. Now, last time I kind of led you into what they should be. This time I want you to tell me what they should be. What's one of our points? Annabelle? 1, 4. What's another one? 2, 8. Another one? 3, 12. And my last one? 4, 16. So let's graph these ones. Okay, again, you could go by 2s, 4s, whatever you really want to on your y-axis. What did you guys want to go by? 2s, 4s? I wouldn't go by 1. 4s?
Yeah.
Okay. 4s make it pretty easy because, again, what's going to happen with these?
Kind of a straight line.
We have another straight line, but this time it has what kind of slope?
Positive.
This time it has a positive slope, which should make sense because on this one, our y values, in this case, or our sequence values, were increasing. On the last one, if you look back at it, your sequence numbers were decreasing. But again, what do we notice about them? The points still form a straight line. Questions, concerns? We're sure? We're ready for this to all disappear? Okay. All right, next up, does the graph represent an arithmetic sequence? Explain. So there are a couple ways we could explain it. Lydia?
Yes, because it's going to
Okay, we could say yes, the points form a straight line. Points form straight line. That would be a wonderful explanation. You could say there's a constant rate of change. That would be descriptive of the slope. That would be another way of explaining it. If there's a constant rate of change, it would be linear. Okay, going along with the idea of constant rate of change, you could say x increases by how much every time?
1.
X increases by 1, while what does y do? While y decreases by 3. All of these would be good explanations to have for, yes, it would be an arithmetic sequence. Okay, questions, concerns? about that example? For sure? All right, you don't necessarily need this whole entire table that's on the screen. You might want to write some of it down. We did talk about a little bit of it already, like A1 being the first term, A2 being the second term. We already went over that. One thing we didn't talk about too much just yet was the position. We usually just label with an N. So in the first position, or the first term you're given, N is equal to 1. That's why the terms are A sub N generically. So if it's in the first position, it's the first term. So when we have a sequence, we can write it using our common difference. So here they wrote it as A plus 1 plus D. So A sub 2 would be your first term plus whatever it is that you're adding. And that should make sense. So like with numbers, if our common difference is 3, we're taking 4, which was the first number. We're adding 3 to it to get 7. To get the third term, we're going to add D again. So we added it once. Now we're adding it a second time, or 2D. So you're taking your very first number, and then you're taking 2 differences. So 2 times 3 is 6 added. We get a 10. You can still see you're adding 3 on this edge number here every time. Okay, so those first few rows are helpful. The one that I consider to be most important, is going to be this last row, because that gives it to us in a most generic way. So in order to find the nth term, whatever the nth term is, could be the third term, fifth term, 27th term, whatever n equals, you're going to take the very first term, and then to it you're going to add in parentheses n minus 1 times your common difference. So this formula specifically, I know I boxed in that whole row, but that formula specifically will be really important. Usually we set this equal to A sub n. Write it again. If you did not write this down yet, you should. I'll write it a little bit bigger and label the parts. So A sub n equals A sub 1 plus n minus 1 times D. So if we label these parts, this refers to the nth term. So whatever number it is they want to talk about. First term, 10th term, 101st term. A sub 1, we've talked about, that refers to what? Which term?
First.
The first term. This is always the first term of the sequence. N refers to the position. So if it's the first term, it's the first position. If it's the second term, you're referring to the second position. Okay, so A and N are kind of similar, but A sub N actually refers to the term, like whatever the actual number comes out to be, whereas N just refers to how many spaces into our sequence are we. D we also talked about earlier, that's the common difference. So whatever our numbers are changing by in our sequence every time we go one position over. Usually what these problems entail would be we're given a sequence and we're asked to find the nth term, like the 25th term. So we have to identify the first term. If we're looking for the 25th term, we would put 25 in for our position number. And then we would have to use the sequence they gave us to find the common difference. And then we plug everything into this formula and use our order of operations to find the term that we're looking for. Need more time on this slide. Okay? Write the equation for the nth term of the arithmetic sequence, then find A30. So A sub 30 would be the 30th term. Let's first focus on writing that equation. So for now, we'll start out with a generic A sub n. I'll write the super generic version up here that we just wrote on the last couple slides. So when we're writing the equation, we don't know what term it is we're looking for yet. We'll do the 30th term in a minute. But generically for the equation, we don't know what term. We want to talk about any old term. Equals. We do know the first term. What is it? 7 plus n minus 1. We don't know yet what position we're talking about, so we'll leave it as n minus 1. Then on the end, we're multiplying by d, or the difference. So what is the common difference for this sequence? -4. Good. We're subtracting 4 every time. Now, I'm going to put that -4 in parentheses so that I remember that it's getting multiplied, not just subtracted. So this is part of our answer. This is the equation we were looking for. So that's our equation. Now we have to find A sub 30. Before we do that, does anybody have questions about the equation?
How do you get -4?
Because on our sequence over here, every time we subtract 4, so we use a -4. Other questions? Okay. Now we find the 30th term. So A sub 30 is what we're looking for. We still are going to use a 7 here, plus, what do you think we're plugging in for n? Which term are we looking for?
The first term. Wait, the position.
We have the first term in our formula. They did give us the second term. We don't need it. In general, what are they asking us to find? Which term?
30.
The 30th. So what position number is that going to be? 30. -1 times -4. So that n number should come from the subscript of whichever term you're finding. Okay, if we're finding the third term, it would be a 3. If we're finding the 52nd term, it would be a 52. Questions about what we plugged in, where, and why? Okay, then we can keep calculating. Now we have to do our order of operations. So by our order of operations, what needs to happen first? Parentheses. Inside those parentheses, what do I get? 29. After my parentheses, what operation comes next?
You add.
Nope.
Exponents.
Exponents would come next, but we don't have any of those. So then after that, multiplication. So we have to multiply the 29 and the -4. I'll move it. 7. What is it?
-116. Oh wait.
Negative.
Well, not including the 7.
1. Well, no, we'll do it one step at a time. So if we multiply, we get a -116. You could put plus a negative if you want to, or you can just put minus. Either way, it's fine. Last step is to do that subtraction. And what do we get? thought somebody had already said it. 7 minus 116.
Yeah. Is negative 109.
Yep, there we go. So the 30th term, or a sub 30, is negative 109. That's the other thing they asked us for in the problem. Now, you could have found that by minus 4, minus 4, minus 4, minus 4, minus 4. I mean, like on and on and on and on until you had done it a total of 30 times. But it's more reliable and usually easier to do it with a calculator. Especially on the next one where we have to find the 50th term. We're not going to want to have to write out 50 terms in our sequence. Questions about letter A? All right, so on letter B, write the equation for the nth term of the sequence, then find a sub 50. So let's work on our equation. How is our equation always going to start off? AN equals. We need a sub 1, or the first term. What is it? 14. Plus, right now we're talking about generically, so we don't know our n, so we leave it as n minus 1. On the end, we want to multiply by our common difference, which in this case is negative 3. Questions, concerns about writing that equation? Now, technically, we could distribute the negative 3 and combine like terms and do all that, but I'm not going to require that. If you can write it like this, that's fine. That is our equation. So now we need to find a sub 50. So again, using that equation that I just made, but what am I going to plug in for n? 50. 50th term would be in the 50th position. Now we're ready to do order of operations. What happens? First, I guess. The parentheses. So in those parentheses, what do I get? 49. The next thing I would do is multiply 49 times negative 3.
Negative 147.
Negative 147. And then last step is to take 14 minus 147.
Negative 133.
Negative 133. Okay, so again, you could have done minus 3, minus 3, minus 3 50 times to get there, or you can use your equation. Questions about these two? Need more time on them. Okay. We can rewrite the equation in function notation. So instead of an a sub n, you can write it with f of n. I don't know that I'll be super picky about whether you write it in the normal notation or the function notation. So literally the only thing that changed was instead of a sub n, we had f of n. Okay. Just a different way of writing it. All right. Online bidding for a purse increases by $5 for each bid after the $60 initial bid. Write a function that represents the arithmetic sequence. This is not a whole lot different from what we were just doing. Okay, instead of an a sub n, we'll write it with f of n. This top row here, normally we would think about it like our x's. Now instead, these are our n's. These are the position numbers. Which means down here, these are our a sub n's. Or the actual value that you get, the term. So, f of n equals, what's my a sub 1?
1.
Nope. 60. The first term is 60. Plus, we are doing an equation, so we're leaving n as n, kind of like when we're doing an equation, x stays x. But on the end, we need to multiply by our difference. So how are the bid amounts changing every time? By how many? $5. Up by 5, so we use a positive 5. So really, this is just like what we were doing on the last one. I will allow us to skip out on the graphing for right now. Okay, letter C says the winning bid is $105. How many bids were there? So this time, we have the 105, that is an a sub n amount, or a function amount. So this time we know that side of it. That's how this is different from the ones we were doing. The rest of that problem, n minus 1 times 5. Okay, the rest of that equation stays the same that it was on the last problem. So we just plugged 105 in for the winning bid on the left side. When we figure out n, we'll be able to know how many bids there were, because n was our bid amount. So there are a couple ways to go about this. Anybody have a feeling about what they would like to do first?
When you put 1 in for the n,
You could put a 1 in front of the n. We're not going to replace the n with anything. We're trying to figure out what n equals. So we're trying to solve for n. That means we got to get stuff away from it. What's something we could get away from it?
you can add, think.
Not yet. Let me give you a hint. I want to get rid of the 60. How am I going to move it? Subtract it. We do it to one side, we better do it to the other. If I take 105 minus 60, what do I end up with? 45. Okay, this is where it gets a little tricky. I want to get rid of this 5. How am I going to do that? Divide, very good. We're multiplying by 5, so to undo that, we divide both sides by 5. What's 45 divided by 5? 9. Now, this last step, I'm sure all of you could get. What do we need to do? Add 1. So how many bids were there? 10. So there were 10 bids. Questions about this problem? Are we sure?